Here we have a very simplified version of the periodic table showing all the blocks. So we're going to go through, we're going to look at S block, P block, D block, and the F block. So we're going to zoom in on S really quick. S is the alkaline earth metals and the alkali metals. We're just going to highlight that really quick, which just means that in this orbital they have 2 electrons. Notice that blank spot right there, that is just helium. That is also part of the S block. And then right below there is the P block. We're going to color code that in orange. And that just means that they have 6 electrons in that orbital. Pretty simple, really common elements also. So we have the D block. I'm going to highlight this one in blue. So as we keep going through the periodic table, there are more electrons in each orbital. So it's like 1p or 1s, 1p, and then you have D, and then D includes a lot of the metals, transition metals. F block, of course, goes right in there. It's just taken out for view's sake, and it is those.
Hydrogen has 1 electron in its s orbital. Helium, an ultra-stable, very low-energy noble gas, has 2. It's happy because it has its shell filled. But of course there are other sorts of orbitals as well. After we fill the first and second s orbitals, we move on to filling the p orbital. Or rather, I should say p orbitals, because we're talking about 3-dimensional space here. So there can be one on the x-axis and one on the y-axis and one on the z-axis. Each of those can contain 2 electrons for a total of 8, with 2 in the s orbital and 6 in the 3p orbitals. And yes, those 8 electrons are the reason for the whole octet rule thing. Remember now, the periodic table is a map of the orbitals as they fill. Elements in the s block are filling their s orbitals. Elements in the p block are filling their p's. Same with the d's and the f's. So s orbitals, very simple, spherical. P orbitals a little bit weirder. D and f orbitals, so crazy. Some of the f orbitals in particular have just ridiculously cool geometries. Lots of fancy math is involved in writing out these wave functions and understanding them. So